All right, let's talk about a modern-day treasure hunt. But forget the dusty old maps and shovels. We're going high-tech to solve a problem that has honestly driven archaeologists crazy for centuries. And it all boils down to one really big question.
I mean, really think about that. There could be entire forgotten worlds, priceless pieces of our own history, just inches beneath the grass. But if you just start digging, one clumsy move with a shovel, and that history is gone. Forever. So how in the world do you see something that's totally invisible?
Before we get to the really cool solution, you have to appreciate just how massive this challenge is. Because for pretty much all of history, the main tool an archaeologist had was a shovel. And just digging, well, it comes with some huge risks.
And this is the absolute best way to picture the problem. You're looking for one specific little toy car in a giant sandbox. If you just start digging blindly, what are the chances you're going to find it? Pretty slim. You're way more likely to just find a lot of sand, and you might even break the toy without ever knowing it was there.
So what it comes down to is this. Digging is a massive gamble. It costs a fortune, it can take years and years with absolutely no guarantee of success, and it's destructive. I mean, you have to destroy the ground to see what's in it. A common technique is called shovel testing, digging little test pits in a grid. But it's so imprecise you could literally walk right over an entire buried house and never ever know it was there.
But what if you could get a sneak peek before you ever put a shovel in the ground? What if you basically had X-ray vision for the Earth itself? Well, that technology actually exists, and it has totally changed the game. It's called ground penetrating radar, or you'll hear people call it GPR. Now, the most important word on this entire slide is non-invasive. That's the whole ball game right there. It means scientists can map a site without digging a single hole, without disturbing anything. They can protect the very history they're trying to find.
So how does this thing work? It sounds complicated, but it's actually pretty simple. The GPR unit, and it usually looks kind of like a high-tech lawnmower, sends a tiny, harmless pulse of energy straight down. When that pulse hits something different, say a rock wall or an empty space, or even just a change in the soil type, it bounces back up. An antenna on the GPR unit listens for that echo and times how long it took to return. It's basically sonar, but for dirt.
And by listening to all those tiny echoes, GPR lets us see things that have been hidden for hundreds, sometimes thousands of years. We are talking about entire buried worlds suddenly coming into focus. And what's so cool is the sheer variety of stuff GPR can find. It's not just one thing. It can detect the sharp outlines of old building foundations, it can spot hidden tunnels and cellars, find forgotten trenches or old water cisterns. It can even locate unmarked graves. It gives archaeologists a map of a world no one has seen in centuries. But here it is. This is the absolute game changer. This is GPR's true superpower. Other tools might give you a hint that something is down there, but only GPR can tell you, with amazing accuracy, exactly how deep it is. And for an archaeologist, knowing the depth, well, that's everything. Now, you might be thinking, this thing spits out a perfect photograph of what's underground. Well, not exactly. The raw data that comes out of the GPR is really just a bunch of squiggly lines. The real magic happens when archaeologists take all that data and turn it into a crystal clear 3D map. And that's a really important point to make. The machine provides the clues, the raw data, but you still need a skilled human expert to look at those clues and interpret what they mean. It's this beautiful mix of amazing technology and human expertise. So here's how they build that picture. An operator literally pushes the GPR unit back and forth across a field in a really tight grid, just like mowing a lawn. Every single one of those passes is one line of data. Then, special software takes all of those individual lines and stitches them together, side by side, to create this incredible 3D data cube of the ground right under their feet. And this is the big reveal moment. It's a technique called time slicing. They can look at horizontal slices of that 3D data cube at different depths. And as they do, suddenly, the true shape of a buried feature just emerges. A bunch of weird-looking signals suddenly resolve into the perfect circle of an old well, or the sharp right angles of a building's foundation. It's the moment the ghost in the machine finally takes shape. So, to really get why GPR is so revolutionary, it helps to see what it's up against. Let's take a quick look at the other tools in the archaeologist's toolkit and see where they have some limitations. Just look at this chart. You've got magnetometers. They're great for finding things like metal or old fire pits, But notice the key limitation. They can't tell you how deep anything is. Then you have resistivity meters. They take forever to use, and again, they really struggle with getting an accurate depth. Are you seeing the pattern here? Time and time again, the Achilles heel for these other methods is the lack of good, solid depth information. And that is where GPR just blows them away.
Okay, now let's be real. It's not a magic wand. It's important to know what GPR can't do. It's not going to give you a perfect image of, say, a small coin. And it can't actually identify bone itself, though it's great at seeing the disturbed soil from where a grave was dug. And it doesn't work so well in certain types of ground, like really dense clay or super salty soil near the coast.
But even with those few limitations, there is absolutely no question that GPR has fundamentally changed our relationship with the past. It's given us this incredible new way to protect history, to understand it before we even lay a finger on it. And this right here is the biggest takeaway of all. The real revolution isn't just about finding more cool stuff. It's about protection. Because they have this detailed map before they dig, archaeologists can target their excavations with surgical precision. This saves a mind-boggling amount of time and money, and most importantly, it protects our fragile shared history from being accidentally destroyed. This quote, wow, it's just so powerful. The data from a GPR survey creates a permanent digital archive. Think about what that means. It means that even if a historical site is eventually damaged or paved over for a new building, that digital record, that ghost map of what lies beneath, it remains forever. So the next time you're walking through a park or a field or even down a city street, just take a second and think about what might be lying dormant right under your feet. Thanks to technology like GPR, we now have the tools to finally listen to those stories, not just by digging, but by seeing. And it makes you wonder, how many of those forgotten stories are still out there, just waiting to be seen?